We are going to talk about polynomials today. So let's first define and look at what a polynomial is. So in this Venn diagram here, everything in the big circle is a polynomial. This is a monomial, binomial, trinomial, and anything bigger than a trinomial is just called a polynomial. So I'm going to kind of skip this for now, writing your own example. Let's just define what they are. Most of you would know that mono means one. So a monomial is an expression that is a number, a variable, or a combination of a number and variables. So if you look up here at your example of a monomial, that's exactly what it is. It's got a number, it's got variables, and a combination of them. So a polynomial would be an expression that has one or more monomial. You probably know from science that poly means many, so it's got many monomials. It's got several. Each monomial is called a term. The terms are separated by a plus sign or a minus sign, which is how you know how many terms there are. If you look up at the binomial, this is a monomial and this is a monomial because they're separated by a plus sign. So I guess a constant by itself then could be called a monomial, couldn't it? Because our definition said number, variable, or. So this one's just a constant. Trinomial, do you see how they were separated by plus and minus so that there were 1, 2, 3 terms? This one has 1, 2, 3, 4, 5. We don't have a special name for it. We just call it a polynomial. So bi means 2, a polynomial with 2 terms. Trinomial, tri means 3 terms. Like terms are, this is important, like terms are monomials that contain exactly the same variables raised to exactly the same exponents. You can only add and subtract terms that are alike. This is very, very important because today we're going to add and subtract polynomials, but you can only combine or add and subtract the terms that are like terms. Now we can multiply or divide anything, and we'll do that next week, but for today we need to know this about adding and subtracting. Then in that Venn diagram, you saw this polynomial not in standard form. Here it is in standard form. Compare the two and see what you think standard form means. What standard form is that you can write this however you'd like. You start with the highest exponent. You list the term, the monomial, with the highest exponent first. So here they put the b to the fourth. That was your highest term. Now the 2 goes with it, doesn't it? The coefficient goes with it. That goes first. Then you go in descending order. I hope that you know what that means. So we're going down, 4, 3, 2. Now when there's not 1, isn't there an imaginary 1? And so what do you end with? You end with the constant, which is just the number. So if I were to write this expression here in standard form, what goes first? Now remember this negative, this minus is attached to what comes after it. So negative 7x to the 5th plus 4x to the 2nd plus 6x plus 9. I started with the highest exponent, went down in size of exponent, ending with the constant. That's called standard form. That's the way we're going to all write our answers so that we can compare more easily if we all do them in the same order. Now let's sort our monomials into like terms. This one is a C second D third. Remember by our definition of like terms, that has to have the exact same letters raised to the exact same exponents. Now here I see the same exponents, but this is an XY, this is a CD, so those are not like terms. This is an xy. Do you see any other terms with an xy? Now the coefficients aren't going to be the same. They may or may not, but the letters and variables have to be the same. So there's an xy, there's an xy, there's an xy. Those are like terms. Remember, I can only add and subtract like terms. Here's a y. I'm going to put a triangle around it. Here's a y. Those are like terms. I don't see any other y's. Oh, my constants would be like terms. I can always add constants together. Here I have an a third and an a third. Those are like terms. I don't have any more x thirds. It's not the same letter, so it doesn't go with it. And then I have x's. So that's how we locate like terms. Those are the only ones we can add and subtract. Now, if I want perimeter of this pentagon, penta means 5, so it has 5 sides. Perimeter means the distance around it, so I add all the sides together. So if I added all the sides, I have 5x plus 9x squared plus x minus 6 plus 4x squared minus 3x plus 2x squared minus 7. Whoops, that's a plus. Now, it doesn't matter what order you list these in. I just added together all the sides. Now, there's no equal sign here. That's why it says expression. I can't write an equation because I don't know the total. I can't solve for x because I don't have enough information. But I can do what's called simplifying by putting all the like terms together. So if I look at this, I have, let's start with the biggest exponent. I have some x squareds. 9 and 4 is 13 and 2 is 15. So all I did was collect the x squareds, the like term. How many x squareds do I have? I have 15 of them. Let's look at the x's. I have 5 and 1 more makes 6. Minus 3 makes 3. And then let's look at our numbers. I have a negative 6 and a 7. That just makes 1. That is the simplified form, simplified in standard form. Expression. We can only make, I'm sorry, my mind wandered. I can only make, I was checking my math there. I can only simplify this and leave it in standard form. I can't solve because I didn't have enough information. So number 7, this expression represents the difference. Difference means subtract, and you see a subtraction right there between the profits at Super Scoop and the profits at Double Dip, where X is the number of cases produced. So you can see how you might use this in some kind of business scenario to figure out, compare, to do some cost analysis. So we want to simplify it and write it in standard form. So I know that in the fall, this tended to confuse y'all. Every time there was a minus in front of a parentheses, isn't it an imaginary -1? So I can look at this a couple of ways. I can look at I'm taking this and subtracting its like term. Or what I prefer to do, because I think it's less confusing, is I will rewrite the first parentheses. They don't change because there was nothing in front of them. They don't change. And then I would go ahead and distribute this -1. I just think it causes less mistakes later. You're less likely to forget it if you go ahead and distribute the -1 first and rewrite it. So negative times negative, because we did that all fall. We distributed a -1 through parentheses. Negative times positive makes that a negative, and negative times negative makes that a positive. Now I can combine my like terms because I have all my symbols right, and that's going to make it easier. So I get 200 x squared minus 12x plus 300. I can't do any more than that. I can't get any simpler. I have combined all my like terms. All right, we're almost finished. Mr. Harrison owns 2 car dealerships. His profit from the first can be modeled by this polynomial. C is the number of cars he sells. Mr. Harrison's profit from the second dealership can be modeled with that polynomial. So we want to write and simplify something representing the difference. And then down here in B, we're going to do the total. You should know from elementary school that difference means subtract. Now it's telling you what to subtract from the first dealership to the second. So the first dealership is this, and I'm going to subtract the second. Now, I hope you will follow me here and let me save a step. If I'm subtracting this, can I go ahead and distribute the negative 1? Minus c squared plus 4c plus 300. All I did there was distribute the negative 1 so that I could just go ahead and combine without having to remember that I'm minusing every one of them. This is the only c third. I've got 2 negative c squareds. I've got a 2c and a 4c. And then I have a negative 100 and a plus 300. There's his difference between the two. Now I want to show total. Total, we know, means to add together. So now I'm just going to add. I don't have to worry about a negative 1, about subtracting anything. I just keep them as is and add them all. Add my like terms. So this time I'm going to have c to the third. Now notice what happens with your c seconds. They cancel each other. One's positive, one's negative. So that actually goes away, and that's okay. There's no reason to put plus 0 there. And then minus 2c minus 400. There's his total. So make sure when you're adding and subtracting polynomials, you only can combine like terms.